switch this on?
We'll get to that in a second. First, let's just give it a good look. Hey, folks, just starting the stream now. Welcome to the weekly Epiphyte stream, where our intrepid team of hackers are trying to improve our prototype direct air capture machine. Today, we are fortunate to have Sandilia, who is at the UPenn lab where we built the initial prototype, which you can kind of see there. We might ask Sandilia, you want to back up a tiny bit?
Yeah.
There you go. Cool. So as we talked about last week, we wanted to just go back into the lab, which we haven't really played around with this thing since December, and kind of take stock of the components that we've been talking about a bit in the abstract, particularly with an eye to the things that we're trying to fix most immediately. And Seth has been there in the flesh with David. He recorded our first tour of it back at the end of the year. But I think this is the first time Tim and Jochen, except for pictures, have laid eyes on it. So first, it's sort of an opportunity for us to direct Sandilia to kind of look at certain parts. And then we'll talk about, with Sandilia, the things that were, namely the sorbent replacement and the sensor replacement. And then maybe we can get into plugging leaks and stuff like that. Sound good, guys?
Sounds great.
All right. Sandilia, do you have any questions to start off with or anything like that? And again, really appreciate you making it in there and giving us the view.
Yeah, so I had one question. So I was to reduce the space between compartments, right?
Yeah, that's exactly right, in the middle. Let me see if I can do another view here that would allow... Here, you know what I'm going to do, guys? I'm going to take us off of the... Give me 1 second here. I think I can do this. There we go. That's probably better. Okay. Yeah, so what David, again, will be on shortly, and I think he'll be very clarifying. Seth, from memory, you might even kind of know a little bit about it. But the main part there, you can see with the wires coming out of it, that's obviously the sorbent where the cartridge goes in. Yep.
The middle part, right?
Yeah, exactly. Where the red wires are coming out.
Yeah.
What's that? What looks like a circuit board hanging off directly in, just off to left of center. Is that to do with the heating control? Or...
Hey, Ben.
Hey, Ben.
Hey, everybody.
Just looking at the Epiphyte, Ben.
Yeah, I'm not actually sure what that is, Tim. Because what you see, this blue box, that's where the Arduino lives. That's actually doing the control.
Okay. Or is it something to do with maybe it's thermocouples or something? All those little wires, maybe.
I don't remember seeing those when I was there. So I'll have to ask David when he jumps in.
It's mystery electronics.
David will clarify.
David will know.
Yeah, he'll know. He'll be on shortly. So, Neely, can you go a little closer to that box that we're just describing about? It would one of the things I'm just trying to assess is the sort of a little bit. Yeah, a little bit closer to the thing that we were just describing in the middle there. The sort of just a little closer to the seams, just to kind of assess where there might visibly at least be sort of leak points. That might be kind of helpful for us to go up a little bit.
Yeah, I could see some space here.
Yeah, there you go. Yeah. So there, guys, I think we were thinking literally just clamping onto that with the silicone layers on it, right, Tim? Is that kind of what we were
Yeah, exactly. And then, if you we're able to cut a picture frame out of something like silicone, and then you could just buy some clamps to go right around each side of the box, squeeze it all together.
Okay, great. And if you want to zip down, Ben, did you have any questions at all? I'm not sure if you've seen this before, except for a picture.
No, I've seen it in video before. What was our question at the beginning on what people were? I showed up right as people were like, "Hey, what is this? What does it do?"
Which part? Oh, that's the. If you back up a little bit, Sandilia. So that's the middle part there that has the wires, that circuit board there. We're not exactly sure what that.
Yeah,
David will tell us about that.
Can you zoom in on that? I'm almost positive that that's just the circuit for the thermocouples. I think they got pretty much the same thermocouples that we had, and they have a little external circuit.
Okay, great. Yeah.
Does that track?
It could
Well,
be.
it looks like it also might be a bunch of power MOSFETs, power transistors. It might. Anyway, we can.
The blue box is what has like all the other circuitry, yeah. So
Yeah,
I mean,
that
yeah,
makes sense.
I'd be confused why you'd want to have. Yeah, no, it does look like there's a bunch of MOSFETs attached to that. Yeah, I don't know. Would be kind of confused by that's external, but
All right. Well, while we deal with that, you want to zoom in. You see where the existing sensors are, right, Sandelia? Those 3D printed black boxes, one on top of the damper
Yeah.
area. There you go. There's that one. Yep.
I guess this one.
Yep. Exactly.
Yeah.
All right. Cool. And those will be the ones that you have, Sandelia. The sensors, the new ones that came in the mail. What's
Yeah.
the sort of the footprint of those? Are they comparable in size to something that could fit into that? I mean, we're going to make a new one, but I just want to get a sense of
Yeah.
how big they are.
Okay, let me quickly open those.
Sure.
Just a second.
The new sensors are on a flex circuit also, so it should be a lot easier to place them where we want.
Cool. We got Ian from Octavia too, who's more on the business development side, but they might jump in. I just asked them in the chat. It'd be good to get some Octavians on the call. All right. Let's tee up some questions. Okay, no problem, Ian. Let's tee up some other things we want him to look at while he pulls out the sensors. What's top of mind for you, Tim and Jochen and Ben is? Oh, I think you're on mute. All right, so for those of you just joining, we're just about to go over the new sensors we're using, and Sandelia, who's in the lab with the Epiphyte, is going to show us those right now so we get a sense of the size of them.
As a quick heads up, I'll have to jump off at 6:30 here. But we'll be around until then.
Okay.
There's some new plastic mounting piece, right, for these new sensors? Have we already got that, or is
Ling has already designed it, and so Sandelia is going to be able to print them out there rather than her mailing them. So we're good, but it'll just be good to take a look at it.
Yeah, maybe a quick question in that. Also, Jochen, I don't know. I think you're trying to tell us something. I still can't hear you yet.
Might be a headphone issue.
I don't know. Do we have any guesses on the? In my experience, 3D printed pieces are not necessarily airtight. Is that consideration for us?
Can you guys hear me now?
Yeah, we can.
Yeah.
Strange.
Okay.
Yeah, what I wanted to say is I wouldn't mind at some point seeing both of those cones on each side of the sorbent panel removed, just to see what kind of surface we have for the material that Tim specified, just to see how much of a surface we have to put the stuff there.
So to take out the cartridge, you mean?
Yeah, I just want to see how much space there is in diameter, so how much material we can put there.
All right, cool.
And the same thing for the dampers. If I remember correctly from the drawings or images you showed last time, these are just metal flaps that rotate on one axle. Is that right? And they are not airtight at all.
There's
This is what
some
we
kind
have.
of gasket.
Yeah, that's what I thought.
Yeah, I think there's a foam gasket in there. So yeah, not the most airtight.
Yeah.
But maybe it would be an idea to put some kind of rubber profile that just fits the surface of the metal sheet, so that if you close them, they are kind of tight.
It's snug. You mean like a gasket, or like kind of like just like a interface between the two metal parts that's sort of a wraparound.
Yeah.
I mean, okay, got ya.
Yeah,
Cool.
I'm ready.
All right. And Ben, to your point, I don't know, Seth, you might have a thought on this. I mean, I think that the external part of the casing is leak proof, but in terms of connecting it, maybe there's like some epoxy or something. I don't know how they were mounted before, if you knew, Seth, but it was probably something we can do to leak proof that.
Yeah, I think it's just a silicon caulk on there.
Cool. Yeah. I mean, I just when I've had 3D printed parts before, like even if you seal, kind of those it, if you push some pressure through it,
You're breaking up a bit.
Yeah, your
Yeah,
sound's a bit weird.
Sorry. Yeah.
It looks like
I possible that the 3D printed part itself is not airtight. We'd have to test for that.
Okay.
Right, printing errors can certainly cause that to happen.
Yeah. Well, luckily we can print out a few. I don't think it'll take that. So, Sandelia, I'm going to put you back on the main view. So you can show us what you look. Oh, you got the sorbent there. A bunch of little. We'll take a look at those and have you taste each one of them if you're up for it. And then, okay, cool. Can that crack open? Can you show us what it looks like? I'm curious to see what the beads are like. That's actually a bit of suspenseful because it wasn't entirely clear. But we'll see just to make sure that they won't slip through like a sieve through our existing netting. If not, we will put them in a little.
Yeah, I'll open one of them, but
Okay.
this is how the sensor looks like, the one. So you see the small part here?
Can you? There you go.
Yeah.
Yeah.
So that's the sensor, and this is the connector. And we'll have to connect this with the, they gave the extra part here. And this is going to be connecting with the power source, and it's going to take in the inputs.
That all makes sense to you, Seth? No surprises there?
Yep, makes total sense.
Okay,
Total sense.
great. So they're not huge.
The sensors
small.
connect to those black cables. The black cables, so there's two sensors, and each of those black cables will connect into, you see the two ports on that little hub,
Yeah.
and then that hub will plug into the Arduino. And that's how we'll get power and sensor data to each one.
Yeah.
Okay, sweet. And if anybody who's watching this right now, we see 13 people are streaming with us. If you have any questions, feel free to pop them into the comments, and we'll go ahead and take those on board. All right, cool.
Yeah. Meanwhile, let me quickly open the sorbent.
Okay.
Yeah.
This is exciting for me. So, let's
yeah,
see.
this is one of the sorbents opened up, and it looks like. Let me try to angle it. Okay. Where's the camera?
You kind of see it. There we go.
Yeah.
What would you say that it's kind of hard to? Is it like sand-like, or is it a little thicker than that?
Yeah, it looks like a sand.
Okay, so we'll probably have to put some kind of a.
Sand more than rice.
Yeah.
It's kind of like quinoa if we keep it in the metaphor. Well, what we could do, what we can do per Joken's request is we can, if you're comfortable with it, so that we could try to open up the chamber.
Okay.
To take a look. And one of the things we might be able to do, guys, whoever would know this better than me, is if it looks like it's going to slip through the cracks, which it probably will, I wonder if there is some kind of like real heat resistant sort of netting or something that is really, really fine grain that could be used to pour that into and then put it in the box. But let's take a look and see first.
Yeah, you could just buy some metal mesh. That'd be pretty easily available. I would do that.
Okay, cool. So, you want to give a whack at trying to open up the thing?
So I was quickly able to open up the hooks that we have to the side.
Okay.
Here. And now I've opened the middle chamber.
Okay.
And I don't know, it's not really movable because maybe it's too much wires, but
yeah.
Give me a second. I'll try to.
Sure.
Yeah.
All right, so for those of you who just joined us, I see about 5 people joined in the last few minutes. We're in the lab at UPenn's Department of Chemical Engineering, where our first Epiphyte prototype has been built. And this is what we're making some amendments to: new sorbent, new sensors, a little bit of air sealing, hopefully adding the vacuum if possible, and test it out from there. So Sandilia is there. And he's just sort of showing some stuff. He just showed us the new sorbent. And right now he's trying to open up the sorbent chamber so he can take out the cartridge.
I opened up the middle part, but I'm not sure how do we take this out. So
It doesn't just.
It does, I'm pretty sure, but I can see where he wants to be obviously very careful with the wires.
the wiring. Yeah.
Seth, do you recall from any memory of? I remember seeing it slide in.
I don't. I think it does just slide in.
Give it a try very gently, Cindelia. Just try to pull out that chamber there.
Hopefully we don't see any catastrophic failures
Yeah,
here.
exactly. All right. Let me see here. Oh, here comes David.
Hello.
Hey, David, what's up, man? We're just going. Sandilia just showed us. He unboxed the sorbent, showed us the sensors, and you've arrived in the perfect time. These guys wanted to take a look at. Here, let me go back to the main view here for him of what we're looking at here. So you guys can see there, just like you've seen images before, that plate there is what's screwed on top that has the sorbent, which is the sort of oatmeal color behind that.
Yeah.
I wonder if that mesh is actually thin enough. One thing we discovered, David, is the new sorbent is a little more like a fine quinoa than gerbil food. So in terms of the mesh, we might, maybe need to put another mesh in there or whatever, but we'll explore that.
Maybe cut a piece of the extra mesh that you see sticking out the top and make a little funnel or something with it and see if the stuff falls through.
Yeah, good call.
Now, you're going to have to, I guess, do some surgery on the wires and stuff. There's really no way around it. And the way it was built, our colleague that put it together had it flat on a table. So the whole thing that's now vertical was on its side, with the part the face that we can see now was up.
Okay, and then it's just a matter of screwing the top off and cleaning it out, putting the sorbent back in the box. And then,
and it's a little tricky getting everything lined up with all those spikes and things, all those pins and everything.
Okay, any questions from you guys based on what you're seeing right now? We did have questions, David, when we just saw it first sight, just some of the that like circuit board that was kind of hanging out the front of where the sorbent cartridge is on the exterior. We weren't quite sure what the purpose of that was, but Ben had hazarded a guess, but I'm wondering if you could fill in the blank there.
Which one?
What was it again, Sandilia? Is that within your line of sight? That board, I think is that it on top there? Or was it? Go down a little bit.
I think it's on the backside of the. It's on the backside of the filter, the sorbent chamber.
So if you pull out a little bit.
Yeah, it's on the backside of that metal piece that's hanging kind of adjacent.
Yeah, 1 second. Let me try to bring it out.
No, it's on on the floor.
Yeah. Just a second.
Oh, okay. Yeah. Sorry. This is the Lord's work to be filmed. Do the filming and find all these pieces.
Yeah, thanks, Adelia. You're the best. We'll try to get you a assistant in there who can hold the camera. Yeah, that was it right there. See that on the bottom there, David? That's
Okay,
it.
yeah, that is all the, they are amplifiers that take the, they're thermocouple amplifiers.
Okay.
So, yeah, so
that
all
makes
those thermocouples that are embedded in the sorbent, they all connect to those little amplifiers, and each one's got its own channel, and then it changes it to an I2C signal that the processor can read.
Okay. Okay.
It's
Cool.
basically A to D converters.
Okay.
Yeah, that makes sense. And the reason that that's not integrated into the larger like circuit board, David?
It was mainly just so it was just convenience. I built the thing gradually by hand. And it's just, I found a board that had some space on it for that, and also just being attached to that front plate like that meant that whenever you had to remove the sorbent panel, there were a lot few wires to tangle.
That makes sense. I didn't want to take up any time here, but I'll have to leave soon. I wrote a comment here. I don't know exactly where that sends in the channel, if everyone can see that or not, but there's a lot of sorbent that we bought, kind of obviously. I just want to make sure. I mean, this is not a paper that I've read, but I mean, obviously it's adjacent to some of the literature I've read on Luetit. And yeah, it's like at ADC, Luetit will degrade with oxygen, rendering it a pretty useless sorbent that's unrecoverable. And so I would just, want to make sure that we. Sorry. My smokes. I'll type it in the chat.
Basically, heat control, you're saying. We got to be really careful with those parameters so we don't toast the sorbent and then make it totally useless. Is that more or less what you're saying? Okay.
Yeah, just want to make sure that we don't, burn all the sorbent that we have, essentially, because it would be pretty easy to do that if we dumped it all in there at once and we're careless with it. I would recommend that we try and, use a small scale. I don't know, try and cycle some of that sorbent at a small scale, or, validate with literature what parameters we can cycle it with, or else we'll probably degrade all of that sorbent pretty quickly and have to buy some more, which wouldn't be the best.
David, how sensitive is our sort of heat control based on what you programmed it to do? Do we have relatively good control over the upper and lower bounds for that?
I think it's pretty good control as long as you set the boundaries in the program to make sure that it doesn't exceed them. And I would just watch it for a while and make sure that it doesn't go too high. Do we know what those temperature boundaries are for it?
Yeah, I mean, I know I'm not super granularly, but at ADC, irreversible degradation will happen. I don't know, obviously it's a range at which temperature degradation starts to happen. And probably a little bit happens before 80, but 80 is the cutoff that I've read before.
What is the lower side of that, Ben, in terms of, do we know what it's in? We did do some correspondence, me and Jochen, with them, but like what temperature needs to happen in order to activate it?
Yeah, no, I mean, it's all like on your isotherms, right?
Yeah.
For whatever kind of temperature you pick. You can go to any temperature above standard atmospheric temperature, and that'll cause some desorption.
Yeah.
It's just a question of how much, working capacity you want to get out of the system. So someone can sit and try and do some math and figure out, okay, if we only go to 70C, what's our working capacity there? Because I'm sure there is isotherms published and that kind of data available for Luatit.
So, David, that's relatively easy to kind of give us a buffer to start off with, right? Where we could just program it where the upper limit would be 70C, just so we don't get
Right.
into danger territory.
Yeah, it would certainly be best to start out conservatively.
Yeah.
Yeah. And yeah, even then it's like, yeah, I mean, let's start conservatively, use a little bit, figure out if it does look like we're losing working capacity over time. Because then, you know, if we know that we aren't, then yeah, go full bore. But I think, yeah, make sure we start slow and conservatively.
You know, I think I should go in there sometime, Sandelia, when you're there, and just show you everything.
Yeah.
It might take a while.
Are there any?
Sorry?
Go ahead,
No,
Jeff.
sorry, David, I interrupted.
I can bring in my laptop and just get the thing running and show you what the things are.
Yeah, sure.
Can I just ask? Is if I think this is right, the heater wire is in direct contact with the sorbent, right?
Right.
Are there any? Is there any? It'd be. I wonder if it'd be quite useful to have some kind of like thermal mass that kind of sits between the two. That will kind of stop any kind of very fast temperature rises, or essentially burning, I guess.
Yeah, that's
Think about it.
Super good point. For our system, we wrapped it in a bunch of like carbon fiber kind of stuff.
Okay.
Electrically insulative, but thermally, kind of offer that thermal mass. That's a super good point because we had definitely a problem of local burning and distributed not great heat transfer. I don't know exactly how the system's set up, but yeah, that's a huge point.
Did you just buy these little carbon fiber, I guess, cylinders and kind of epoxy them onto the heater wire?
No, so we got like a carbon fiber, wrap, and we just had bare nichrome wires, wrap those, and then we wrap that in some there's like thermal tape that you can buy for systems like this.
And these wires are wrapped in a fiberglass sleeve, which was probably overkill. I was looking for something that could handle, 400 or 500 degrees, and it turns out we don't need anywhere near that. So there might be better ways to do it, but that would mean taking the thing apart. As far as thermal mass, you've got a huge thermal mass contacting the heating wires in the form of the aluminum structure.
Right.
And that's what makes it really hard to heat this up very fast.
Mm-hmm.
And that was one of the things I identified as something that needed to be fixed for the next revision. Maybe make the frame of a different material or something, or have some offset so it doesn't channel most of the heat away from the sorbent.
Yeah, is the heater wire actually attached to the back of that aluminum plate, or is it basically is the aluminum plate kind of pressing it into the sorbent? No.
Nice.
I think it is. It's some of both. It's on the corners. It makes this sort of zigzag. Yes, you can see that. And yeah, it's just attached to the corners where it changes direction. But other than that, it's pressed against the sorbent material by the sorbent itself.
So it's essentially partially, slightly buried inside the volume of the sorbent.
That's what would happen. Yes.
Yeah.
Could you put some sort of insulated material at least around the walls of the square? So like behind the little connection points that the wires are threaded through, like whether it's an adhesive or something that would cause it to not insulate it from the metal. Obviously, you're not gonna be able to do it with the whole lattice structure, but at least to the biggest mass of metal. It looks like there's space. Yeah. What would that material be? Does anybody have any ideas for that? Something that could easily be just taped in there, or?
A relatively easy thing might be something like PTFE. No, that's not too difficult to cut.
Okay.
Cool.
Oh,
Yeah.
also,
Question. The way we looked at the sorbent panel just now, where is the air blown in? On the side where the heating is, or on the opposite side?
It's on when you're, go ahead.
there's heating on both sides. So
Ah, right.
we go back to that picture.
Sure. 1 second. 1 second. 1 second. Here we go. Show and that.
The side that is down now is the side the air enters from. And so
Yeah.
then, by the way, it may not be easy to see in the picture, but wherever those wires make their bend around those pins, there's a grommet, a nylon grommet that keeps them from actually touching the pins. So there's a little bit of thermal insulation there. So I would think, though, that most of the heat transfer away from the sorbent is just where it's touching the metal screen below it and those aluminum bars, the grid shape. So then the sorbent is poured on top of that, and then there was another set of wires identical in length and configuration that went on top of the sorbent, and then the screen and yes, there you go. That's the top part, and then the screen was put on top of that.
Ah.
So it should be symmetrical.
Is there any reason that we couldn't move the two sets of grommets in towards the center of the pins so that we're actually essentially burying the wires inside the sorbent volume, and then they're as far away from the outside panel screen as possible?
That I think would work, and then just use one set of wires or have both sets of wires moved.
No, that's good. I was just in the same thing. I don't know whether whether there's enough, the duty cycles you were using were low enough that there's enough power from one. But I guess
could you do it like a layer cake though, Tim, where you do a half a centimeter, put one down, then fill up another one, then put another one down, and then fill up it on top?
Yeah, I think that would make more sense because then you don't have to heat. You don't have to have. It will just be quicker, and
It would be quicker.
You don't run the risk of feeling the need to turn the power up to warm it up quicker, which will just get the temperatures higher locally.
Okay.
I will say though that these wires are kind of stiff, and they're not stretched like piano wires. They're just kind of laid down as best they could be. So it might be hard getting them if you want to divide the thing in thirds. That might be a little tricky.
Yeah.
All right. Let's check in with Sandilia. I'm curious what questions are coming to your mind as you are looking at this, my friend.
So I was just trying to understand how do I install the new solvent. So just a second. So I'm assuming I'll have to unscrew the pins over here.
Yeah.
These pins and also these pins. And I guess the inner structure was something that you guys showed me like a second back.
Yes, you would have to unscrew those the nuts, and as those pins, I think you have to get them out somehow too.
Okay.
I mean, those pins aren't structural, right? So we could also, there probably isn't. They might not be much heat going through them, but they could also just be something that isn't steel. Actually, it probably doesn't. Sorry, it actually probably doesn't matter much. There's probably not very much heat conductivity through them relative to those panels.
David,
I think you're right.
David, quick question though, just going back to what you said earlier. So you were thinking because the grommets were there and they were creating a space that most of the heat transfer probably wasn't happening on the sides of the box, but rather from that lattice pattern right there. But we think okay.
That's my guess.
All right, got you. Sandilia, when you look at it close, just eyeballing it because it's hard for us to tell the mesh there. When you look at how fine that mesh is, and you looked at the sorbent, just dead reckoning, do you think that the mesh is wider than the sorbent particles, or that it looks relatively?
Just give me a second.
Sure.
I feel like the sorbent is finer than the mesh.
Okay.
Yeah. So maybe we'll have to double it down, or maybe create a new mesh.
Did we have leftover mesh at all, David? Do you know?
I don't know. It would have been left there on the cart someplace if we did.
Okay. Because you could do a layer that is a bit offset from the other one, I guess, that would just create more warp and woof there. That would make it difficult for it to fall out, or maybe there's a finer grade mesh.
It also means more resistance to the air.
Know. Yeah.
I mean, you can buy, you can buy meshes with various hole sizes. If we knew what the diameter of those, or smallest dimension of those sorbent particles was, we could get them maximum, the mesh with the largest hole size possible.
And I know this is a silly question, but David, where are these light switches for the lights to be turned on here?
The lights?
Yeah.
Oh, in the lab?
Yeah.
Oh, they're downstairs. They're under the stairway, kind of on these. You have to reach around a pillar.
Okay. Okay, let me quickly.
No problem.
And then go to your left.
So for the software part of it, is it relatively easy to kind of swap out parameters in the code, David?
Yes.
Based on what okay, got it. For the sensors,
He has to set up a programming environment on his laptop so it'll compile it and everything. It's just a standard Arduino kind of IDE setup with all the libraries and everything.
All right, cool. Again, I want to welcome the 28 people who are watching us right now on stream. I think it's best to make a comment if you go to the StreamYard itself, which you can click on if you're looking at this from different sources. I'm not sure if the comments show up if you post them from LinkedIn or from X. So. All right, cool.
Yes, David, can you quickly guide me? Is it to the right or left?
Oh, the lights?
Yeah.
Okay, go to the right.
This side, right?
Yes, that side.
Okay.
Keep going. Keep going. Slow down. Turn left.
Turn left.
Left
Okay.
90 degrees. Nope,
Okay.
nope. Back.
Oh, this side?
Yep. Now turn right 180 degrees.
Where all those refrigerators are, there's a little gap between the back of those refrigerators.
Oh, so these are the
Okay, back.
the pillar. So
Back, it's behind those.
back side of those.
Oh, okay.
You have to go the other way, though, the way you came from.
Oh, okay.
All right, everybody getting a tour here of the Fuller context here. We got.
Okay, stop.
There you
Stop
go.
there. You see a pillar in front of you? Reach behind it. I think that's where they are.
Oh, okay. Oh, yeah.
All right. Bueno.
Yeah. It's hard.
Sandilia, I know I've said this like 10 times, but I really want to just say how awesome it is that you dropped into our lives when you did. So with your expertise, so thanks, brother.
Yeah, I guess now you have a better view.
Yeah. Yeah. Tim or anybody, do we have any other thoughts on like a thing that could be inserted into the box that would allow us to have something that can hold a finer grain sorbent, but also maybe allow for more air to flow through, like almost like something we could insert that would like columnize it or something, you know?
I mean, I think the first thing is the easiest thing is just to find a different mesh with a larger hole size, which is going to hold the sorbent in. But I mean, I think there has to be a mesh, right? I don't think there's any other any other way of doing it.
Yeah, I'm just worried about the trade-off, obviously, between resistance and securing the, making sure it doesn't fall out, because that stuff's valuable. So we definitely want to keep it snug. All right.
I mean, I think there's a good chance.
Sorry.
No, go ahead, Joachim.
I still come back to my question I asked before. I do want to understand better what happens between the side of the sorbent where the air is blown in and what happens on the shadow side where the air is not blown in, and whether the surface that sees the blown in air is saturated with CO2, but the rest of the sorbent doesn't get to see any.
I mean, I guess the question is, does any air actually blow through this system? Is another way of, is that,
Well,
I guess, another way of asking it.
We know that some does because the fan is on the output side, so it's drawing air in and you can feel it from the input.
Yeah.
Okay,
Also, I've done absorption, desorption cycles, and the desorption phase, when it's heated up, you definitely see CO2 being registered by the sensors up to, 1,000, 1,500 ppm or so with the fans off. And there's always more that comes out on the input side than the output side. So I think it's what you're thinking is right, that it's preferentially absorbing it on the side where the air blows through.
Are they? is there any chance that basically no air is, the resistance is so high through the sorbent but there are actually air channels around the whole picture frame, and that when you
that's a good point, and that's another reason it's important to get an airtight cavity.
Mm-hmm. Well, just coming back to my question before then, if you've seen that phenomenon, David, that's fine. The only thing then I'd like to bear in mind as we go forward is we need to make sure that we think about the fact that maybe on the side where the air is blown in, there might be more CO2 released during the heating up, so that we somehow manage to capture that as well on the other side.
I mean, would a vacuum help with that if there was the vacuum on the other side as well, that it would kind of like suck it through to the other side, or no?
Yeah, sure it would, but you have the same effect. The sorbent panel acts like a kind of wall between the two, and the bottleneck is the part where the sorbent is. So if you blow in air on one side, and that's where you capture more CO2, and then you apply the vacuum on the other side, where you have less CO2, then obviously you're not going to see all of the CO2 that you captured more on the receiving side.
We talked last time about having that split system, right, for the vacuum, Jochen, where you'd have like a little T thing. They would basically apply the vacuum to both sides of the chamber to resolve that very issue. Is that right?
Yeah, but that needs to be closed during the capture time.
Right.
I mean, the reason to be having a fan on each side is that you basically increase the pressure differential across the sorbent, and so get a higher flow rate. But I think we need to establish that the way that the sorbent is packed into that picture frame isn't so tight that that effectively there's little to no airflow through it, because otherwise we'll just have the problem that only the volume of the sorbent right up against the front surface where the air is being blown in is ever going to see much airflow, come into contact with the air, and then that's the only portion that's absorbing CO2.
Could you put little dividers like in the thing, or would that just cause all the air to immediately flow through there and not even? Or I guess it wouldn't matter because the air would already come into contact with the sorbent. I just wonder if there's like a little buffer or a little gap we could put in the sorbent panel box that's very thin that allows some air to come through?
Yeah, I think that could work. I think the only other thing I'm thinking is that I just think about, Octavia. This is design is based on what they did, and I don't think they did anything special, because I've seen the video of them looking inside their sorbent box, and I think they didn't, as far as I could tell, they didn't put any spaces in there. But I think maybe the problem is it's going to come down to the size of the sorbent and its shape.
Yeah.
And if we've got tiny little grains, then if you don't, the natural thing for us to do is just to basically all closely pack together. Whereas if you've got bigger pieces, then you keep there's a lot of there should be potential for a lot more airflow.
Well, I have an idea. 1 second. Is part of it about packing? I mean, if we didn't pack it as much and there was some movement there, and I wonder if with the fan, if it wasn't fully packed, would that cause turbulence where you might even have like a popcorn effect with the sorbent if it had a little bit of space, that it would kind of cause it to move around a bit? Do you see what I'm saying?
I mean, I guess if that was going to happen, then you'd probably have left so much space that it was just going to kind of like sag down. I mean, it's all going to fall down under gravity if you left too much space in.
But with the power of the fan, though, I mean, possibly these are little tiny grains.
The grains at the top, like blow them around. I doubt. It wouldn't.
It doesn't feel like it would affect the entire volume of grains.
Right.
But I mean, I'm wondering if we kind of kill two birds with one stone by doing that layer cake approach. So instead of one layer a couple inches thick of sorbent, you've got, say, 3 layers, each an inch thick, with its own heating element. So now you're heating up a smaller amount. You're pushing the air through a smaller amount of sorbent, and then it gets to the next layer.
There's another thing we can think about, and that is we have plenty. Well, this would be a mechanical rebuild, but we're only using an 8-inch square section of the picture frame.
Yeah.
If we could spread that out, make it wider, but from front to back it would be thinner. So with the same amount of material, there'd be less distance for the air to have to go through. There'd be less resistance. But then you'd have to basically rebuild the thing.
Let's take a look at that again.
Just following on from that, but a slightly different issue. If you look at the actual thickness of that whole picture frame there, it's actually quite a lot thinner than the filter box size, and that's going to be a problem when we get to the point of trying to pull a vacuum on, because there's no mechanical support on either side to stop the whole thing bending together.
Which part is that, Tim? So you mean the difference between there's that empty void on either side of the box? Is that what you're referring to?
Yeah, so that's exactly. So the thing we on screen at the moment, that's an inch in thickness, and then I think that filter box itself is actually about probably 3 inches. I think. I mean, David, you know this, but I mean, I definitely saw when we opened it up that there was a big gap. That thing doesn't fill up the entire space.
Right. So the reason is it was meant to be modular and adjustable, and those big bars you see going vertically and horizontally across it are sort of like Legos. It's called 80-20, and you can supposedly screw them apart and move them around. So without having to buy too much new parts, theoretically, those could be adjusted in their location to make a bigger center well there. And the thickness is just because that's the thickness they come in. But there should be some flexibility there, but it's not that easy, because then you have to get a bigger screen, get that grid that sort of provides the 4x4 grid that provides mechanical support for the screen. That would have to be provided somehow. You'd have to get longer heating wires or just stretch out the ones you have, so they wouldn't be as much coverage. So it would be a job.
Okay, but you could separate it to make that wider, which would make it a thinner layer of sorbent. And with other screen, you could potentially put the screen then on top of that and something that, so when you put the plate on it, something that's like a divider, or that would, keep that top screen. So you're not doing 3 inches, you're doing 1 inch, but it's wider, so it's the same amount of sorbent. And something we could jerry rig potentially that would make it not move around. Like, I don't know what we would put in there that would, between the plate and the top screen, that might keep it snug.
Yeah, I think my instinctive reaction would be to make the surface as large as possible and as thin as possible.
Yeah, exactly.
And one more, I actually thought that these 2 cones on either side were fixed to those profiles. I wasn't aware of the fact that we had this, like a box in between where there was space. So that obviously, that's why I suggested putting some rubber into those slots there. But obviously, if there's space left and right, that doesn't work.
Could we also, Tim, to the concern that you had about the empty spaces there, you thought that would be problematic with the vacuum, right? Is that what you were saying?
Yeah.
Yeah, we could probably put something in there too.
Yeah, no, you could. You just need to fill it up.
Yeah.
But I mean, at the moment, this thing is only 1 inch thick, right? So that's the maximum amount of sorbent. I mean, I did those calculations, which were to give you, David. I think you did these before, right? But just given the volume of sorbent we've got, we can kind of estimate whether we're not going to have very much CO2, but we're going to have enough that we can actually measure it. And I think there's still quite a bit of room, so we could still have a lot less sorbent and still have a measurable signal when we drive the CO2 off.
Yeah, just to test it out. I'm just trying to think of the things that we can do now with minor hacks. And then the bigger question of having it be longer and thinner is a thing we can design for on the next build. So with the remaining 5 minutes, I want to kind of tend to Sandilia's questions and needs here, particularly with David on. David, do you think it would be possible to meet at the lab with Sandilia based on your availability?
Yes, I have a few days this week I could come in. Should we just talk about it offline, Sandilia?
Yeah, David.
Great.
Okay, I have your email.
Yeah.
Okay. Cool. And what questions or thoughts do you have right now, Sandilia? Today we just kind of wanted to go back into the lab, take a look at all the stuff so that we knew exactly what it was like rather than in the abstract. Yeah. But what are your immediate needs and thoughts?
So for now, I'll try to understand based out of the GitHub link that you sent of how the whole system is integrated, and then sort of reached out to David with any questions.
Okay, great. I will also, have you talked to Peter at all on Sandilia? I know he did have an interest in coming into the lab at some point, but curious if you've spoken to him about that. I can reach out to him.
Yeah, I reached out to him. He said he would be free this week, but I am yet to hear back from him.
Okay. So maybe in an ideal world, we might have a situation if you two meet, maybe Peter's free at that time too. I think it would be useful to kind of transfer some of the practicalities to him as well.
Okay.
So I'll send him an email with you guys copied.
Yeah.
And you're going to have to figure out how to get rid of the sorbent that's in there. I don't think you can just turn the thing into the sink.
Yeah. So I'll mail Madeline about it, and whatever procedure she tells me, I'll do that.
Okay, awesome, Sandilia. Appreciate it. All right, we're getting near time. Anybody else have any questions or thought? I think it was illuminating to see this. We just had a lot of great exchanges, but David or any of you guys have any thoughts?
No, but it was a good exercise.
Very good. Yeah, I'm excited. So maybe even by next.
Something's happening.
What's that?
I'm glad to see something's happening.
Yeah, no, me too. And particularly if you guys meet up this week, I think next week will be quite interesting. So this is great. All right, well, we can go ahead and say goodbye to our 36 viewers. Again, folks, I did add the link to the digital deck, which will give you a sense of all the different things that we're working on this spring before we make revisions and rebuild, revise this one and then build a few more in other parts of the world. So please take a look at that and be in touch. But thanks for tuning in. And thanks, everybody. If the rest of the team wants to just hang on for 1 second while I end the stream, we do have a couple minutes. Let's just chat for 1 second. But thanks, folks. See you next Monday. All right.